Hello, PLMS. Today we are going to be writing an equation given a line. I can write an equation in the form y is equal to mx or y is equal to mx plus b by looking at a graph. Remember the equation y is equal to mx plus b, where m is the slope or the rate of change and b is the y-intercept. Another way that we have been talking about the y-intercept is the beginning. It doesn't mean that it's the beginning of the graph, it's just the beginning for us in terms of where we start to count. Just kind of gives us a guideline as far as what kind of or where to look for points on the line. So the y-intercept is always a good place if the graph crosses the y-axis. Here is our first example. So this goes back to direct variation. Write an equation of the line and slope intercept form. Right away, I notice that this line goes through the origin, goes through the point 0, 0. So if the graph goes through the point 0, 0, then we know that the equation is going to look like, I'm just going to go back to what we talked about before, y equals kx. Now we've kind of graduated from that, and now we use y is equal to mx instead, or y is equal to mx plus b. We'll kind of talk about how those two go together in this example. In order to write the equation, I need two pieces of information. I need the b, or beginning, and I need the slope. So this graph crosses the y-axis right here at 0. So I'm going to go ahead and just fill in 0 for my y-intercept. And as far as the slope, the line is going down, and I find another point on the line here, and then you can already see that's been highlighted for us. So basically, in order to find the slope, we need the rise and we need the run. Well, this line is going down. So from the origin, that's the place on the y-axis that we want to start. We're going to go down 1 and then over 1. So we rise 1 and we run 1. Remember, rise can be up or down. So think about when you're in an elevator, like you would go up and down for the rise. And it's negative because we went down. So we went down 1, which is negative, and we went right 1, which is positive. Now that's really going to simplify down to -1. Then to plug it back into the original equation, y equals m is -1x, and then our b term is 0. And so that's why we kind of have this connection between y equals mx and then y is equal to mx plus b. Because if I plug it into y equals mx plus b, which we did here, then our b term is just a 0. So we just really simplify that down, and all we really need from this equation is y is equal to -x. That is our final answer in terms of writing the equation. And then before you go on, just kind of think back, because you've already been using the equation and you've been having to graph. Well, the equation here is y is equal to -x. Well, that means that negative in front of it, that's a -1. We know the slope then is a -1, and we know that it goes through the origin. Of course, that's exactly what's happening with our line. So let's leave it as y equal -x as our final answer. So in other words, something you can draw from this conclusion is if it goes through the origin, you will not have that plus b term. It would just be y equal mx. All right, so I'm noticing on this example also that it does go through the origin. So if it goes through the origin, I really am just going to be using y is equal to mx. Step 1, find the y-intercept, or the place that the graph crosses the y-axis. We already said that 0. Step 2, find the slope of the line. The other line was going down. This one is going up, and it's traveling at the same rate of change. It's just going up 1 over 1 each time. So up 1 over 1, up 1 over 1, and so that slope is going to be 1. When I go back to substitute it into the original equation, y is equal to, whoops, I moved my 1. Let's bring it back down here. And to substitute it back in, my ink does not want to work today. Let's try this. There we go. So y equals 1x, and if it was the plus b also, well, 0 is b, so that's not going to change the equation. The best way to write this is just simply y equals x. You'll also know this as the parent function. The parent function simply means that it goes through the origin and it's traveling at a rate of change of 1 each time. On the last example, we would call that the negative parent function because once again, it goes through the origin and it's going down 1 over 1 or has a negative 1 slope. You're going to do something with that later. All right, so once again, our goal is to write the equation. In order to write the equation, I need b, or the beginning, and I need slope. Now this one's going to be a little different because I noticed that it does not go through the origin, so I am going to need the entire equation y is equal to mx plus b. Here's our origin, 0, 0, and I notice it goes through the y-axis right here. So I'm going to start at 0 and I'm going to count down 1, 2, 3, 4, 5, 6. So that means my y-intercept is negative 6. And then the slope of the line, I just need to find another point that crosses an axis. And I find a couple. I see one here and I see one there. B for beginning. So I'm going to go to the y-intercept and I'm starting here at negative 6. And I remember we are rising first and then run. I notice it's going down. So we're going to go down 1 and then over 1, 2, 3 and repeat that process. Down 1, over 1, 2, 3. So our slope is negative 1/3. Once you have the b and the m, then you can simply substitute it back into the original equation. So our final answer, y equals negative 1/3 x, the slope is always first, and then the y-intercept is negative 6. That, my friends, is writing an equation in slope-intercept form. Alrighty, here's our next example. In order to write the equation in slope-intercept form, we need b, or the y-intercept, and we also need the slope. So this graph crosses the y-axis right here at 0, 3. I don't need the whole ordered pair, I just need the 3. As far as the slope is concerned, it is going up. I'm trying to see the constant rate of change. Looks like it goes through here. Yeah, I think it's supposed to be this one here. Yeah, that works. I had to see what the constant rate of change was. So in order, we're starting here at the origin, so we're going to go up 1, up 2. So we rise 2, and then we run 1, 2, 3. Both of those are positive because I went up 2, which is positive, and right 3, which is positive. And then we want to double check. Once we got to this point, we go up 1, 2, and over 1, 2, 3. And that, of course, does work. Once you have the slope and the y-intercept, then you substitute it into the original equation, y equal mx plus b. So y equals 2/3 x, and then it's a positive 3. There is your equation. And I notice some things here. First of all, it goes through 3, and also that it's a positive slope, which you can see that the line clearly goes up. Why don't you pause the video and see if you can do this one on your own. Pick out the slope, pick out the y-intercept, and then just substitute it back into the equation. I wanted you to notice this is our final answer. Welcome back. Y is equal to 3/2 x plus 3. So when I go to the y-intercept, I notice that I'm at 3, and I rise 1, 2, 3, and I run 1, 2. But let's say just another thing for when you were graphing, if you remember back, here's our y-intercept. I could also go down 1, 2, 3, because remember rising is up or down, and then left 2. So if I do that, then that meant I went down 3, which of course is negative, and then left is also negative, and then that simplifies down to a positive 3/2. So that's just something else to consider in terms of finding your slope. Final answer, y is equal to 3/2 x plus 3. And this is just a recap of graphing. So it kind of tells you like where you were going before. You had the line, and now, of course, you are given the equation. So we need, how are we going to get there? All right, so in order to graph, then I need the b for beginning, which is 4, and I need the slope, which is -3/2. So go to the origin, and we go up 1, 2, 3, 4. And it's a negative slope, so from that point I count down 1, 2, 3, and right 1, 2, and I repeat that process down 1, 2, 3, right 1, 2. And I like to put as many points on my line as possible. You know, you've heard me say that before. It just makes it easier for me to use my tools, and also make it easier for you to use your ruler. So I'm going back to the y-intercept now, and also because I want this line to go through, this is quadrant 1, I want it to also go through quadrant 2, so that would be up 3 from the original point, up 3, 1, 2, 3, and then back 1, 2. So how does that work? Because remember, it's like that negative can go with either of the terms. So if it went up 3, then that negative would go with the denominator. So it's just something else to consider. I'm going to continue here. So there's my final point. Pick up my tools, and then I want to connect my points that go through the entire coordinate plane. That one's a little bit thick. Let's see if I can find one that's a little thinner. Make sure that you have arrows at either end and that it goes through the coordinate plane. I hope you enjoyed learning how to write an equation from a line in slope-intercept form, and then also just the review of graphing given the equation.